Good morning, dear students. Last session, we have started talking about cables subjected to concentrated loads. So let's see what we have seen in the last class. We have solved a problem, an example problem that I'll just go through once again. So we have, first. Had a count of total unknowns in the problem. Then we have now counted the total equilibrium equations that are required for solving the unknowns. Okay, so let us see that one now. Uh, let you see H is the unknown, RAY, because you have a hinge here. So 2 and 2 here. So total 4 external unknowns and 1, 2, 3 and 4. So total 8, 4 plus 4, 8 plus geometry 1, 2. So total 10 unknowns are available in the problem, right? So to solve these 10 unknowns, so don't forget to count the geometric unknowns also. Geometry, which means the sag or dip of the cable at selected locations where the load is applied. Why we are only taking this as unknown? Why not the other locations? Because once you know this value and you already know this span value, and once you can calculate this value, if you want y value at any other places, you can easily calculate it. So without knowing this is not possible. Okay, so that is why we are taking this as unknown, right? Similarly, at all other locations, why we are taking the geometry at the load point as unknown, right? Okay, so you have 10 unknowns, and joint A, joint B, joint C, joint D, and joint E. So total 5 joints. So at each joint we can write two equilibrium equations, which is sigma fx0, sigma fy0. So we will have total 5 into 2, 10 equations and 10 unknowns. So this problem is a determinate problem. Okay, so I have explained how you solve this problem in detail in the last session. Okay, so this session also we will see some example, which is a simple one. I'll go back to the empty sheet where I can easily explain with a simple problem, not of this much big scale problem, right? 10 unknowns you have. We'll go for a problem with lesser unknowns. Let us see. So let me draw one simple problem. You also try this along with me. So let me say two hinges at the two ends, which are at same level. So there is a cable joining these two. So if there is no load on this, your cable will look like this, right? So imagine that, so this is some, the span of this is 10 meters. Okay, so let me take this size. Okay, Right, so this is of 10 meters. Okay, right. So let us assume that there is a load of some 10 kilonewton, okay, at some 2 meters distance. Okay, got it. So what happens when you apply the load? The cable settles down and it will just deflect like this, isn't it? So now you just name all this. Okay, this is A, right? Support B, support C. So load now is here. The 10 has come down. Okay, now count the unknowns. You have to solve this problem. Solving means what? What is the tensile force developed in the cable? Because you are applying a force of 10 kilonewtons. So if there is no 10 kilonewtons, the self weight of the cable itself will cause the no, the load internal force in the cable, right? So now that is negligible. Self weight of the cable is negligible, right? So you have 10 kilonewtons, right? So now what is the internal force developed in the cable? That means the tensile force, right? So how many unknowns? Hinge at A, two unknowns. Hinge at B, two unknowns. Plus there are two portions of cable, AC and BC. So two cable tension values, and Y at C, dip or sag. Geometric unknown is 1. So how many total? 7. So what you need? 7 equations or something. 7 conditions or something like that. So how many joints you have? A, B, C. 3 joints. Each joint 2 equations. Okay, so 3 to 6 equilibrium equations. Okay, got it? So 6 equilibrium equations. Now you need 7. Then what about the other one? It should be given, okay, or it should be measured, something like that. So what I assume here is, let us assume y at C is equal to some 0.5 meters. Is a given that. Okay, right. Let us see how you solve this problem. Okay, so now the sigma Fy0. Okay, so that you apply sigma Fy0. Now what you do, you remove support A. Free body diagram of the cable first need to be drawn. Okay, so reaction, vertical reaction, horizontal, vertical reaction. What is this one? HA. What is this one? VA. What is this one? HP. This is VB. Okay, right. So what you do first when you are given a problem, you do something like this. Unknowns you count and equilibrium equations you count. See that you are able to solve. Okay, means whether the problem given is determinate or indeterminate. If you don't estimate like this, if something is missing in the problem given to you, then you will just keep on working and you don't get the answer. Okay, so before, if you analyze like this, then you will know if anything is to be assumed or any data missing or something like that. So for example, if the examiner misses the data to give IC value, then you immediately notice it, and you will be in a position to assume that value. So the data is not given. Let us assume something and proceed, give you the answer, right? So that's how you can command the problem solution if you have full control over this procedure. Okay, right. So let's proceed further. So first thing, estimate the unknowns, estimate the equations and conditions given in the problem. See that it is a determinate problem. Number of equations is equal to number of unknowns. The very next thing you need to do, draw free body diagram of the cable. Means what? Remove the supports, then apply reactions. Okay. Now your job is to find these four unknowns first. Then you go for the remaining unknowns. So what we do? So we have equilibrium equations called sigma fx0, sigma fy0, sigma m0, right? So let's write sigma fx0 first. So what does it mean? All the horizontal forces sum is equal to 0. So what are all horizontal forces? There are only two. One is to the left. Let's call it as no, minus, plus acting towards right. I take it as no, positive is equal to 0. Only two forces, that's all. So what will happen? So always HA is equal to, if there is no horizontal force given on the cable, right, as H. Right, going for the next equation. Sigma Fy is equal to 0. Okay, got it? So what are all vertical forces are there? VA taking upward as positive, plus VB minus 10 is equal to 0. Got it? Now what? VA plus VB is equal to 10. Let this be 1, this be 2. Now what is the third equation? Sigma m is equal to 0. Where do you take? You take anywhere. Maybe at A or at B, whichever point you want, or at C, whichever point you want. So we'll take either A or B to avoid one unknown into the equation. That is the idea. So sigma, we always prefer B to get VA value. Sigma MB0, some clockwise or anti-clockwise direction, positive, whichever you want. So take moments about B of all the forces in the structure. Sum of all the moments from all the forces. Okay. So right. So taking B, VB distance 0, HB distance 0. Even HA distance is 0. It is passing through. So how many you have? Already three quantities are not having any moment at B. So only two, VA and 10. So write that one. So VA is giving you clockwise moment. So minus VA into total span is 10. That means what? Distance between VA and B. Uh, 10 is going to cause anti-clockwise moment. Got it? So anti-clockwise is taken positive. So 10 into distance between 10 kilonewton and B is 8 meters. 10 minus 2 is equal to 0. Okay. So what is VA value? This 80 by 10, 8 kilonewton. Got it? Then what will be, now if you take it as 3. Okay, so try substitute this 3 into 2, we'll get VB. 10 minus 8 means 2 kilonewton. Okay, got it? So you got VA value, you got VB value, and there is one more value left. What is that? H you have to find. How you find it? You know the condition that on the cable at any point bending moment is 0. So I select C. Okay. So I apply moment at C is equal to 0. Got it? So you are taking a section at C. Sum of all moments either to the left or to the right is equal to 0. Remember, this is different and this is different. This is equilibrium equation for the free body. Okay, this is moment at a section is equal to 0 is a condition. Okay, so for this you are taking all the forces, whereas for this you are taking either to the left or to the right of the section. That should be very careful. So moment at C is equal to 0. We are applying that because cable cannot take bending moment. That's why moment will be 0 on the cable at any point. So I take the left part. Okay. So sum of all moments about C to the left is equal to 0. So H A is equal to H. So H into distance YC. This is horizontal force. Perpendicular distance between C and H is equal to YC. What is YC assumed? 0.5. What direction it is? Anti-clockwise. So what is left anti-clockwise? Hugging minus. Here you have either anti-clockwise or clockwise can be positive. There is no condition there. There is no limitation. But here you should follow the sign convention. Left clockwise positive, left anti-clockwise negative, all that, right? Got it? Then next H is over. Then VA into the distance is 2 clockwise. So left clockwise is sagging. So what is VA value? So let us first write the equation, then we will substitute. VA into 2 is equal to 0. Okay. Now substitute VA. What is VA? 8. So H is equal to 8 into 2, 16. divided by 0.5 means what? 32 kilonewton. Okay, so this is only to find external support reactions. Okay, right? Okay, we will come back to the remaining solution in the next lecture. Okay, thank you so much.